Hi, today I'm talking about LeetCode problem 1551, minimum operations to make an array equal. This problem asks you to write a function, min operations, that takes an integer in as an input. And so in describes an array of length n, where each indice in the array has the value of 2 times the indice plus 1. And what it wants you to do is find the number of operations it would take to make all the values of the array equal to one another. And when I say the number of operations, it describes this operation for you, where you can provide it two indices, and the value at indice 1 is reduced by 1, and the value at indice 2 is increased by 1. So this illustration I've made may make it a bit more clear what's going on. So you get an indice in equal to 1, 2, 3, 4, 5, 6 equal to 6, and that means you have the first 6 odd numbers. So I, in this case 0, plus I 0 times 2 plus 1 is 1, 1 times 2 plus 1 is 3, and so on. So we have this list of the first n odd numbers, and what we want to do is find out how to make all of these numbers equal to each other, using only the operation that increases any index by 1 while decreasing any index by 1. So the example that LeetCode gives is if n is equal to 3, what's going to happen is you have this array 1, 3, 5, the first 3 odd numbers, and you can choose index 2 and index 0, 2 to decrease and 0 to increase. So you increase this, or you decrease the 5 to a 4 and the 1 to a 2, and then you do that same operation again, decreasing the 4 to a 3 and the 1 to a, and the 2 to a 3, and then you'd have your result. All the values would be equal. They're all 3. So when I was thinking about this, the first thing I tried to do is just work through a couple examples on my own and try to figure out what the algorithm is or should be. And what I noticed is the midpoint of this array, that's where all the values are going to be converging. And the reason I thought of that is because you are adding to one index by the same amount that you're subtracting from the other, you need to be converging on an equal point. You can't change the sum total of the values in the array because you increase by 1 and decrease by 1. So you need everything to converge into the middle, or the median. So in this case, the median is 6 when I'm using n equals 6. And I want to converge all the values to 6. And so I just took the sum, just kind of testing this out for myself to see if this would work. I summed up the difference between each of the values on the left-hand side and the median. So 1 is 5 less than the median, 6. 3 is 3 less than the median. 5 is 1 less than the median. So I just have 5 plus 3 plus 1 is 9. And I did the opposite thing, the difference between the values on the right-hand side and the median, to get 1 plus 3 plus 5, which is kind of the exact opposite. 5 plus 3 plus 1, 1 plus 3 plus 5. So yeah, it seems to line up. I realized with the median, there's two possible cases. One is that the median is contained within the array, or alternatively, that the median is not contained within the array. So if there's an even number of digits, the median value isn't going to be contained within the array. It's going to be calculated by the midpoint between these two values, between the middle one or between the two middle values, so that there are 2 values less than this, 2 values greater than this. The other possibility is that you have an odd number of digits in the array, or that n is odd, 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is odd here. And in this case, the median is going to be contained within the array. So I just checked that out for myself to see that the same logic still applies. We find the median, 9, and we sum up all the values. We sum up the difference between all the values on the left-hand side and the median. And then we do the same thing with the right-hand side. And there what we find is they are balanced. So 2 plus 4 plus 6 plus 8 for a total of 20. And just the reverse for the left-hand side. 8 plus 6 plus 4 plus 2, total of 20. Another way to think about this is that for every value over here on the left-hand side, there's kind of like an analogous value or a matching value over here. So I just need to increase this 5 by 4, and I likewise need to decrease this 13 by 4, and they'll both arrive at the median. So I considered that there's a special case. What if we just have one value in our array? And in this case, if we have 1 or 0 values, we basically don't need to do anything because the answer is 0. We don't have to make any changes to make one value equal to itself. And then finally, I considered this question. What is the median of the first n odd numbers? I tried to consider if I could just calculate that or if there was some formula or expression. But I didn't think about it too hard because I was just eager to get programming, I guess. And I felt like I had a solution already, so I didn't want to worry myself coming up with a better one, maybe unnecessarily. But I believe there is probably a way to calculate this without actually doing all the work that I'm about to show. But anyway, one helper function I have is just a function to find the median of an array. And to find the median, I just find the midway point in the array, so the length of the array, integer division by 2. If the array is an even number, that's going to be the case where there are essentially 2 midpoints. It's the half point and one before the half point. So on the whiteboard, it's this case where, let's see, n is 6, so 6 integer divided by 2 is 3. The midpoint here is 3. So we'll use 3 and the one before it as our median. The average of those two values will be our median. Yeah, so that's what's handled there on line 4, is that special case, half the time case, where the length of the array is even. We're going to find the 2 midpoints, divide by 2, and I'm just going to parse it as an int. It's kind of guaranteed to be an int anyway because both of these values are odd, so 2 odd numbers will add to an even number and can be evenly divided by 2. But we need to parse it to an int because the solution, the LeetCode solution, expects integers as an answer and not floating point values. So even if we were like 6.0, LeetCode wouldn't like that. It wants 6 exactly. And so then the main function that's going to solve this problem is just this one, min operations. And what it does first is handle the special case. If n is 1 or less, then we just return 0. We don't have to do any operations because a single value is already equal to itself. That's kind of my Zen comment. And then what I do is I just construct this array, which I'm calling nums, and it's just the first n odd numbers using the same formula that the question provides, 2i plus 1 for I in range of n. I use my median function to find the median. The half is the halfway point of the list. And then what I'm going to do is I'm just going to find the sum of the differences between the indices in the first half of the list. Between the values in the first half of the list and the median. So I is just going to go between 0 and the halfway point. And for every increment of I, we're going to add or accumulate the difference between the median and the value in nums at the index. And when it completes, we will have the right answer. So I guess I can just I guess I'll just draw that once just to be perfectly clear. Here our median is 6, so we're going to iterate through the first halfway point, or while I is less than the halfway point, which is 3. And we just take the difference between median and the value here. So it's, 6 minus 1 plus 6 minus 3 plus 6 minus 5. And that will get us our answer. 5 plus 3 plus 1, or 9, which is the correct answer for the number of operations that we need to equalize them out. And so I'll submit it. The time is kind of varying, but it's not the fastest solution. As I mentioned, there are, analytic solutions or mathematical calculations that you can do to just avoid actually creating the array and calculating the median and all that. But I didn't think of that when I was writing my own solution. But I assume these are going to be much faster than actually producing an array. So that'll do it for this problem. I'm going to aim to produce a LeetCode problem a day, or to solve a LeetCode problem a day for the foreseeable future. And every time I solve it, I'm just going to walk through my solution and try to explain it. So if you're interested in that, you can click the like button, you can subscribe and watch the videos I'm putting out, or you can let me know in the comments, especially if you have questions about this or want to see a specific LeetCode problem or something similar to LeetCode problems. Yeah, I'm interested in it. So thanks for your time. Bye-bye.